Hi, I'm Jed. I'm going to show you today how I would lay out and measure a stair on a job site. We're in my shop, but we're going to pretend that we're going to be building a stair from here to here, and I'll go through the whole procedure of measuring and laying out a story pole to try to show you how to make the stair as accurate as possible. When I go to a job, I bring a set of plans, I bring my auxiliary brain, my notebook, I bring a tape measure, I usually bring a folding rule, and I bring a laser level, and I bring a laser measure. I found that laser tools have really helped me get more accuracy when I measure sites. Now, the first thing that we do when we measure a job site is we measure the floor to floor. In a stair, the most important safety feature is to have all the rises be exactly the same from top to bottom. And when I say all the risers be exactly the same, I mean the finish risers. From the finished floor to the top of the first tread, from the top of that tread to the next tread, from the top of the top tread to the top of the flooring on the landing. All those dimensions need to be the same within 1/8 of an inch. Code allows 3/16 of an inch. That's not close enough. You can stumble over 1/8. So we try to keep it within 1/16 in our work. So we have to measure the rough floor to floor first. And to do that, first I look on my plan, which is usually a 1/4 inch scale plan from an architect, and I see that the stair starts, say, up here on the second floor, but it's a dogleg stair. It comes down this way with a flight. We'll have an intermediate landing right here, then the stair will turn 90 degrees, and it'll end right here. So when I measure my floor to floor, can I hook right here at my second floor and measure down to my floor? That's 101 1/4. Is that my rough floor to floor? You'll find that when I ask these rhetorical questions, the answer is almost always no. We've got to measure from here, where the stair starts, to here, where the stair finishes. This floor here could easily be 1/2 inch below the point under the second floor landing of the stair. If this was over a bearing wall, for example, floors almost always, as you know, slope away from a bearing wall. So we need to get our rough floor to floor from where the stair starts to where the stair finishes. And by far the easiest way to do that is using a laser level. You see we're projecting a level line already here at about this height. So I can quite easily measure down here from my landing and find my laser line. And that laser line is at 59 3/4 inches. And I'm going to write that down in my book so I don't forget it. And start a new page for this job. Then I can go to where my stair starts and I can measure up from the floor. And here I get 39 7/8 inches. One tool I forgot to mention, which is probably the other most important tool, other than your tape measure for building stairs, is a Construction Master calculator, or a foot-inch calculator. As far as I know, this is the only foot-inch calculator which will really work for stair calculations. And I'm going to give you a whole series of keystrokes which will enable you to lay your stair out very accurately. So the first thing we do is we add our distance from the second floor down and from the first floor up to get our rough floor to floor. I'm going to push the clear key a few times to make sure there's nothing in the calculator's memory. Then I'll go 5 9 inch 3/4, 59 3/4 inches, plus 3 9 inch 7/8 equals 99 5/8. That's my rough floor to floor. Now can we start with that 99 5/8 and go right into dividing that by an even number and get our net rise per tread? Of course the answer is no. We have several other things we have to know. we have to ask the architect or the owner what the thickness of the finished floor is. How far is the finished floor above the rough floor here, and how far is the finished floor above the rough floor here? We can't frame our stair until we know these two things, because when we lay anything out, anything in building, we start with the finish and we work back to the rough. The finish is what the final product would be. We have to know what that is before we can design the rough. Okay, now we know that 99 5/8 inches is our rough floor to floor. Can we just divide that by the number of risers and that'll give us our finish net rise? No. We have to know a few other things. We have to go to the architect or the owner and find out what is the thickness of the finished floor downstairs, what's the thickness of the finished floor upstairs. Then we can find out what our finished floor to floor is. Let's say that this gets 3/4 inch tongue and groove. So we can add 3/4 to 99 5/8. We just go plus 3/4 equals. What about this floor? Let's say we have 2 inches of mud and 3/4 inch of Mexican tile. Or let's say we have something we see very often, which is 1/2 inch of hydronic board and 3/4 inch of floor. This floor now is coming up 1/2 plus 3/4. That's 1 1/4 inches. So we have to deduct 1 1/4 inches from the rough floor to floor to get the finished floor to floor. All I do is I go minus 1 inch 1/4 equals. Our finished floor to floor is 99 1/8. I'm going to write that in my book. 99 1/8 fin floor to floor. That's a very important dimension. Now let's find out what the finish riser height is going to be. In a residence, I found that 7.5 is a good place to start. That's a very comfortable rise for most people. So I will divide 99 1/8 by 7.5 inches to find out how many rises there are. I've got 99 1/8 in here. I'll go divide 7 inch 1/2 equals. Well, that's 13.21667. So we're going to have 13 rises at 7.5. Then we'll have a little one at 0.21667 times 7.5. Now we can't do that. We have to round off. So let's round off to 13 even. So I'm going to go back to my 99 1/8 by multiplying times 7 inch 1/2 equals. Now I'm back to 99 1/8 and I'm going to divide it by 13. Divide 1/3 equals. So you can see that our finish net rise is 7 5/8. And I'm going to write that in my notebook too. 7 5/8 net rise. That's the distance between the top of one finished tread and the top of another finished tread. From the top of the finished floor to the top of the first tread. Now, is it exactly 7 5/8? Well, actually, I doubt it, because it's very tough to divide any number by 13 and get an even number of eighths. There's actually a little hidden fraction, because I've set this calculator to default to even 16ths, because I'm a finish guy. If you were a framer, you could set it to even quarters, maybe. So there's a little hidden fraction in there. Anything that's smaller than a 16th is not going to show. But the calculator knows that number. And we want to avoid making errors that result from cumulative additions of very small numbers. Let's say it was a 32nd less than 7 5/8, the real net rise. And we had 16 rises. If we had 16 times a 32nd, we could easily end up 1/2 inch off at the top. So we're going to use the calculator's ability to remember those little tiny remainders to lay out this floor. And the way we do that is I'm going to push memory plus. I've now put this number 7 5/8 plus or minus this tiny fraction into the memory of the calculator. Now we're ready to build our story pole. And I'll usually select a clean ripping like this one. This is a piece of poplar. I've cut the end square, and I'm going to hook it with my tape and make some marks on it. I always set my tape up so the numbers are right side up. If it's easier for you to put your tape upside down, don't do it. Because it's very easy to make a mistake, go 25.5, except when the tape is upside down, you've moved in the wrong direction and you've actually gone to 24.5. So let's put our tape right side up, hook it on the end of our story pole, and lock it right there like that. Now we can make very important. When we detailed down this tread, we detailed 1 1/16 down for the thickness of the finished tread, plus 3/4 for the plywood. When we did the landing, we detailed down 3/4 for the tongue and groove flooring and 3/4 for the plywood. And the next tread up, 1 1/16 down for the tread, 3/4 for the plywood. And if we look with our tape, we'll see that it's 7 5/8 from the top of this tread to the top of the landing, and 7 5/8 from the top of the landing to the top of the next tread, all as well. What did we have to do to make that happen? Well, you'll see that from the rough here to the rough at the landing, that's 7 15/16. But from the rough at the landing to the rough at the next tread, 7 5/16. That's 5/8 of an inch different. If we had made them all the same in our ignorance before we made our story pole, we could have a very unpleasant interview with the building inspector when he found out that these two treads were 5/8 inch different in height.